Thank you for attending today's Train the Trainer workshop, and thank you for giving us an opportunity to discuss our B Fundamentals program with you. We understand that many of you attended one of the launch webinars in Hawaii, Nevada, and Illinois that we had in earlier this month. So thank you for you to coming back to have more in-depth discussion with us today. And for those of you who did not attend the previous webinars, but would like to know more about our B Fundamentals program overview, please come to our program webpage where we posted our presentation slide and a recording. And the link to our program webpage is on the chat box. And a few housekeeping items. Today's session will be recorded and the presentation slide and recording will be available. And if you're not speaking, please mute yourself. If you have any questions, please feel free to write in the chat window or raise your hand so we can give you a chance to speak. Next. So B Fundamentals, Building Energy Education Fundamental Programs, introduces community college students and young professionals to energy efficiency and energy code topics to prepare them to integrate energy efficiency into their work. And this program is funded by the Department of Energy's Office of Efficiency and Renewable Energy. Next, please. And the Smart Energy Design Assistance Center, in short CDAC, developed the B Fundamentals program and curriculum. And CDAC is an applied research program at the University of Illinois. And our mission is to reduce the energy footprint of Illinois and beyond. Next, please. There are also partners from 3 states who collaborated with CDAC for this program. They are state energy offices in Illinois, Hawaii, and Nevada. And also, as you can see from the list here, we also have participants of the program from many different sectors and industries. Our participants are from community colleges and universities, K-12 schools, municipalities, state agencies, utilities, design firms such as architects and engineers, construction companies, contractors, consultants, and professional organizations. Next, please. And next, we'll do some introductions. And first, I would like to introduce Ian Blanding, energy analyst from the Pacific Northwest National Laboratory. Ian has been working closely with the project team by providing guidance and support for the success of the program. Ian?
Great. Thanks, Sumi. And thanks, everybody, for being here. I'll keep this pretty brief because if you've attended the last workshops, you either heard from me or Chris Perry from DOE. But yeah, again, just really happy that you're all here. We're really excited at the Building Energy Codes program to be at the pilot phase of this and to see this curriculum be put into the classroom or job sites or your offices and really see it get out into the world. Because as you know, with energy codes and any other energy efficiency building program, they're only as successful as they are in terms of implementation. And so, and proper implementation takes training, takes education, it takes a workforce that really knows how to put those into practice. And hopefully that's what we'll get out of this program. I think it really does a great job going from building science through energy codes, through some of the advanced technologies, and really will prepare the workforce for that. Aside from this program, I wanted to just take a quick second to let you know that this is only part of kind of a longer term investment from DOE in terms of training and education. So you may have seen as part of the Infrastructure Investment and Jobs Act, $225 million was appropriated for building energy code implementation, specifically implementation of updated building energy codes over the next 5 years. And a large emphasis of that funding is on workforce development. DOE has issued requests for information on how to most effectively spend that money, to get at those goals outlined by Congress. And so, we hope if you have the time, would love for you to take a look at that request for information and provide any feedback you have, in terms of what works, what doesn't, what can move the needle in terms of improving training practices and implementing energy codes and other building efficiency policies and technologies. And so I'm going to drop the link to that request for information in the chat. The timeline to submit comments is until May 20th at 5 p.m. Eastern. And so please, feel free if you have any insight. You all are the trainers and educators in the field, so we would love to hear from you. So that's it for me. Thanks so much, Sumi.
Thank you, Ian. Next slide, please. So from CDAC, we have 3 speakers today. First, my name is Sumi Han, and I am the Assistant Director of Operations and the B Fundamentals Program Manager. I'm also managing the Illinois Energy Code Training Program, where we provide resources, technical support, and training for Illinois professionals. Through our Illinois Energy Code Training Program, we provide continuing education credits such as AIA CEUs and ICC CEUs. And Linda and Sean are content experts of the B Fundamentals program. Linda is a Communications and Education Program Director, and Sean is a Senior Engineer at CDAC. Linda?
Hi, it's good to see everyone. I have been involved in the B Fundamentals program since it started, and I helped to lead the needs assessment. So I've talked to a few of you during that needs assessment to figure out what was needed as we prepared our curriculum. It's good to see everyone here, and looking forward to our discussions today.
Great. Sean?
Hi, I'm a mechanical engineer, one of the technical content experts for our Energy Codes training program here in Illinois. I've got a background in mechanical engineering. I've done blower door testing for residential buildings. So I had a lot of collaboration on the testing, commissioning of buildings, and the mechanical sections of the content.
Great, thank you. And next slide, please. So now let's spend some time getting to know you who are participating in today's workshop. We have sent out a short pre-workshop survey, and many of you responded to our survey, so thank you so much. And some of you responded that you plan to use B Fundamentals curriculum, and some of you responded that you're not sure. So hopefully we can address any questions or concerns that you have through today's workshop. And you also told us that your courses train students for diverse careers, such as electricians, architects, energy auditors, construction managers, building operators, HVAC installers, engineers, and resort managers from Hawaii participants, and code officials. So we are very excited to have educators from so many different fields. So let's hear from our participants. So you see some of the prompt questions here that we listed, such as your name, organization and position, and how are you involved in the training, why you're considering teaching B Fundamentals, and what do you hope to learn from this workshop today. So if you want to get started, anybody, just unmute yourself and just don't be shy. This is a small group. Anybody want to start first?
Well, I can start. So my name's Eric Calderup, and I'm a energy efficiency consultant, independent consultant, and I'm involved in training and education, I guess, in two ways. One is that I've done a lot of work with the state of Hawaii on energy code training. So training to mostly professionals and building officials. And then I also teach a college class in building systems. And so a good sort of both of those perspectives.
Great. Thank you, Eric. Anybody else?
Hi, Sumi.
Hello.
Let the other gentleman go first, then I'll go.
Okay, my name's George Wisniewska. I'm a mechanical engineer, energy engineer. I am a licensed professional engineer. I work with Chicago Public Schools as a building assessor. I'm VPI certified building analyst. I'm a law professional. Energy auditor by Association of Energy Engineers. I've been doing training previously on a previous state of Illinois project, weatherization, basically for BPI standards, teaching people how to do blower door tests and things like that.
Thank you, George.
All right, Sumi, this is Lynn Nielsen. Can I go next?
Yes, please.
All right, my name is Lynn Nielsen. I am with the City of Henderson, Nevada. I am the manager of plans examination services for the City of Henderson. And my team is the one who's responsible for ensuring compliance with our adopted energy code so far as the plans and the designs are involved. We have another manager at the City of Henderson who's involved in the enforcement side on the inspection part of it. But that's my organization and how I fit into the organization. I'm involved in the training of my staff, and I also assist the other manager in the training of his staff. And the reason we're interested is primarily to get to know more about the B Fundamentals program and to see how we could use some of the modules in the training of our staff. So we appreciate the opportunity. Thank you, Sumi.
Thank you.
My name's Jim Andrews, and I'm an assistant professor at Kauai Community College. I teach electrical installation. I teach the solar classes and also the HVAC classes. Been here about 10 years. Before that, I was at Ogden Weber Tech College in Ogden, Utah for 25 years.
Thank you.
Sumi, this is Michael Bill. I'm inspector for Highland Park, Illinois, electrical and mechanical. I also do the plan reviews for them. We're in quite a robust construction phase right now with a lot of multifamily and basically condos and also apartments going on in the village. And it's energy conservation certainly is part of that. And in my past experience, I've been an electrician most of my life, but I'm also a contractor, an estimator. And so I feel that from this course, I can basically address my other fellow inspectors and disseminate some of the knowledge of that. Like I mentioned before, we watched Sean's presentations on different energy codes in Illinois. And I also teach estimating for NECA, National Electrical Contractors Association in the Midwest and Boston. And we are starting to not just only work with contractors, but also with electrical graduating electrical engineers that want to get in and need to know about estimating. And I can see the whole commissioning contracting force developing around this, because somebody needs to enforce it and actually know what they're doing about it. So the more I can know, the more I can throw out there. Thank you.
Thank you.
Sumi. Hi, everyone. I'll be real brief. This is Abby Brokaw. I'm a program manager for the Illinois EPA Office of Energy and a sub-grantee of CDAC for the B Fundamentals program.
Thank you, Abby.
I'll go next. I'm Frances Fig from Triton College in River Grove, Illinois, and I'm the chairperson for Architecture, Construction Technology, and Renewable Energy Technology. So hopefully we can incorporate these into several classes.
Thank you, Frances.
I'll go next. Aloha, my name is Amy Shirama. I'm an assistant professor at Kapiolani Community College in Honolulu, Hawaii. We teach a new class called Sustainable Resort Design and Operations. And I've attended the other workshops, and we're looking to see how we can incorporate some of these lessons into our course. So thank you for this.
Thank you, Amy.
Hi, Sumi. This is Gabriella Martin. I'll go next. I'm the program director for energy at the Illinois Clean Energy Community Foundation. We've been running a net zero energy building grant program and net zero energy wastewater treatment plant grant program for about, I think this is our sixth year now. But as such, we have become kind of a resource hub, and we spend a lot of time educating folks that are interested in going down that net zero energy route. So wanted to attend this to kind of do our job better, I guess. So thanks.
Thank you. Well, if you haven't introduced yourself and would like to, this is your chance. If not, we'll just move forward.
Yes. Hi, multitasking. Hi, it's Debbie Rowe. Glad to be back here today and to learn more about this valuable curricula that I'm sure many will use. I work with community colleges and across the country. I run an international workforce education for green jobs initiative with multiple UN agencies. I co-organize the National Clean Energy Workforce Alliance, and I work with a wonderful group of faculty and the Illinois Green Energy Network and the Community College Network in Illinois, working on very similar goals in terms of updating curricula and career guidance and job placement and getting the workforce that we need for a clean energy transition.
Thank you, Deb. Any last volunteers? If not, let's look at our slide. So Linda, you need to swap the view. Yeah. So this is today's agenda. Today's agenda includes the following items. So first, we're going to talk about why teach building energy fundamentals. We're going to spend like 15 minutes, and Linda's going to present that part. And then we're going to talk about intro to B fundamentals, a very short presentation from me to navigate, our program page and Instructor Toolkit and our Moodle site. And then example module, and this will be presented by Sean, and it's about the introduction to energy code. It's from our Moodle content. And then we're gonna do breakout room activities for scavenger hunt, syllabus scavenger hunt. And then we're gonna come back to a big group, and then we'll do 15-minute group discussions and led by Linda. And then we will do wrap up and call to action, last 10 to 15 minutes. Next, please, Linda. And Linda, you can take away from here.
All right. It's good to meet all of you and see some familiar faces. I just attended the excellent workforce discussion that I believe it was Carrie led yesterday. So just happy to have everyone here with us. I wanted to discuss a little bit, and I know I'm preaching to the choir here, but why teach building energy fundamentals? Why we feel like this curriculum is necessary. And again, our focus has been on community college and trade programs, but also professionals. And our assertion is that all building related jobs address energy efficiency in some way. So energy fundamentals are essential for architects and engineers. They need to learn to design for efficiency and ensure code compliance and safety. Contractors and construction managers need to learn to build efficiently and make buildings more efficient when they renovate. We've got a lot of people, a lot of contractors we work with who do installation or who are technicians. So learning a little bit about those building fundamentals will help them install efficient equipment and make sure that it's operating properly. And then finally, building operators. We teach a lot of them as well, ensuring that buildings run smoothly and efficiently and are maintained efficiently. We also, another goal of this program is to inspire students to enter energy efficiency careers and building code careers. We know that, that there's a shortage in many areas of the country of energy efficiency workers. Throughout the United States, this was from the 2021 US Energy Jobs Report, and 86% of construction employers in energy efficiency reported that it was difficult to find qualified job applicants. And 97% of professional and business service employers reported that it was difficult to find qualified job applicants. There's lots of jobs out there, and there's going to be even more with the Infrastructure Jobs Act. And we need to be able to fill those jobs. So part of our goal with this curriculum is to inspire students to enter those jobs. Building code careers, there's also a great need for people to join the codes profession, the regulatory profession. You can see here in this little graph that many of our code professionals are going to be retiring in the next 10 years. And we'll need to be able to fill those jobs. Sorry, go back. In short, we did some research on the energy efficiency workforce in Illinois. We collected quotes from employers, and we found that overall there's a lot of demand and not enough workers. So these are just a few of the quotes that we got. These in particular come from the weatherization workforce. One person said, we've got a number of agencies who have pretty sizable wait lists, but there is insufficient resources to provide assistance to all the people who need it. And we asked if it was just money that they were lacking, and they said, no, it's the crews to do the work. And one person said, regardless of the type of job, you are always needing more people. We could constantly bring them in here. One person said that they needed crews doing the work. Another person said, we need more assessment folks. And that would trickle down to needing more contractors. So thinking about the need for energy efficiency workers, the federal infrastructure bill provides $73 billion for energy and power. And a good chunk of this is going to be for energy efficiency jobs. So energy efficiency work. So the question that we are facing now is, are we going to have the workforce to do that work? And I believe the answer right now is no, which is why your job is so important. We asked employers what they wanted of candidates, and we're not going to go over all of the results we found, but in general, people wanted qualified candidates, and by that they meant they wanted people to have trade skills, to know how to use tools. They mentioned energy efficiency basics, and we'll be talking about how our B curriculum is really focused on that. They wanted workplace skills. They wanted basic academic skills and personal effectiveness skills. And even though we are emphasizing this energy efficiency basics, I want to, just put out there that there's so much more to education beyond just that content knowledge piece. So I appreciate all of the good work that you are doing to work on these other areas of training as well. So we found that the trade and community college programs, the employers who worked with students out of these programs, they felt like they were covering the basic carpentry, mechanical, technical skills, those construction skills, those trade skills and workforce skills, but not enough energy efficiency, not enough of the energy basics. So one person said, people don't get a ton of exposure to energy efficiency in these programs. One person said that they don't often address whole building approaches. And then there's a lack of exposure to the energy code. So many students have very little exposure to the energy code in their training. They may be exposed to other codes, but energy code is often seen as this orphan, this thing that comes last behind all of the other safety codes. And energy code training is at a state level, and this is our program too. It's focused on continuing education for existing professionals, which is certainly very important, but it's not necessarily focused on training new professionals. So that's kind of the focus of our training curriculum. Can we meet that need for new professionals, for students? I wanted to share a little bit of background on, okay, so if we want those energy efficiency basics, where does this fall? So we looked at Department of Labor competency models for the kinds of jobs that you are teaching, that you are helping your students get. These jobs have a lot of different things that they need to cover. You need personal effectiveness competencies, academic competencies, workplace competencies. Industry-wide technical competencies are really where the building energy fundamentals are. This is where you need, and the Department of Labor specifically lists that the kinds of jobs in these construction fields and power and energy fields, they need to understand the fundamentals of energy and power. They need to understand energy efficiency, and they need to understand policies and regulations. And this is where energy code falls. And then on top of all of these competencies, there's industry sector technical competencies and competencies that are required for certain jobs. But we're focused here in B fundamentals on these industry-wide technical competencies that cross lots of different jobs, any job that relates to buildings, essentially. So next we asked, okay, so what are the building energy fundamentals that students need to know in these different jobs? We turned to the Department of Energy's Building Science Education Guidelines for answers to this question. They identify four core training areas that students need to know. And these areas are integration of the whole building system, building science principles, operations and maintenance, and building testing, and energy codes is included in building testing, among other things. And our education program, our B program, specifically focuses on these building science principles and energy codes. So just to give you a feel for some of those basic building science principles that students need to know, DOE emphasizes the following topics for building science principles, and the highlighted ones, the red highlighted bolded topics are addressed in our envelope modules. And the highlighted topics on these slides are addressed in our mechanical and electrical modules. So basically all of the building science principles are addressed, the fundamental principles are addressed in our modules, and that's really the focus of our curriculum. Building testing principles, you can see that there's more than national codes and standards. We address commissioning and diagnostics a little bit, performance monitoring a little bit, but really we focus a lot on these national codes and standards in our modules, focusing on the energy code, of course. And this is specifically addressed in our introduction modules, but they're also addressed throughout the modules, throughout all of them, because we feel like energy codes aren't a standalone topic. They need to be integrated into all of these other topics. So Department of Education, DOE, Department of Energy, their building science education guidelines focus on proficiency levels. And I want to emphasize here that depending on the professions that you are teaching, you may have different proficiency levels. Some require higher levels, some jobs require higher levels of proficiency, actually creating something or evaluating something based on the knowledge. Other professions, depending on the topic, may only need to read or understand or apply. So in general, because our modules are seen as fundamentals, as basic knowledge, we focus on levels 1 to 3. These are introductory courses to topics that should apply to most professions. And to give you a feel for some of the things that we do to try to reinforce learning, our presentations and videos, they help students remember and understand the topics. A lot of our worksheets and quizzes, discussion prompts, in-class activities, they try to help students apply what they've learned. And really, we're anticipating that you have curriculum of your own and activities of your own that will help the students apply or even analyze and evaluate the material. So this, I'll just go over this quickly, but this is a few of the building science principles that students are expected to learn. And here are 3 jobs. There's many other jobs that are listed. You can go into guidelines if you're interested in what the different competency levels are for different professions. But the average general contractor, they need a level 3 for heat transfer. That is, they need to be able to remember and understand it and apply it to the work that they're doing. National codes and standards, you notice that almost across the board, all of the professions required a level 3, which is they need to be able to understand codes and they need to be able to apply them. They need to be able to open up that book, figure out what's required, and be able to design buildings or construct buildings that are code compliant. So just in general, our curriculum will start out more basic and get more advanced. So this is one of our modules. This is some subtopics about indoor air quality and ventilation. You can see we start out often with a fundamentals unit, and then we move on to standards or more more advanced topics, energy code requirements. And we've broken it up so that you can select the content that is most appropriate for your students. So depending on what you're teaching, you may not need to cover all of the sections of each module. Start with the basics, and then as depending on what your students' needs are, you can get a little bit more advanced. You're certainly welcome to teach all of them, but feel free to pick and choose. It's organized in such a way that these different units can stand alone. And now I'm going to turn it over to Sumi, who's going to just provide a very brief overview of our fundamentals curriculum. I know many of you have seen this before. Hopefully you'll learn just a few new things.
All right, thank you, Linda. So let's look at our B fundamentals program and our Moodle site briefly. So this is our program page, and if you click the link on the chat window, then you will come to our program page, which includes a lot of information. But here we're going to just briefly talk about the Instructor Toolkit and access to our modules. Next, please. So if you click the Instructor Toolkit, and this is where you would come, and this is where you can get information about more of our program, and then how to use our curriculum. So about our program, you can get answers to questions such as, what is this training program about? Who should use this program? How can I be involved? And then under using our curriculum, we have answers to questions such as, how should I select which curriculum to use? And how do my students and I access some modules? Because we designed our Moodle site so it has a slightly different privilege if you are instructor or students. So example, we don't give out quiz questions the quiz answers to the students, but we do provide answers to the instructors. Next, please. And then this is just a little snapshot of our curriculum. If you come to the Instructor Toolkit, and there are 4 group submodules. So intro groups, and envelope groups, and mechanical and electrical groups, and advanced group, and total of 15 modules here. And you can preview, without logging into Moodle, you can just look at briefly what kind of materials are covered in our curriculum. Next, please. And this is an Instructor Toolkit, and briefly, we kind of organize in a way that presentation, worksheets, in-class activities, and videos. So these materials are all kind of, embedded in our Moodle curriculum, but, under presentation, this presentation, we have a PDF version and PowerPoint version, and those are meant to be shared in class or through online lectures. And we try to make it simple, so it's not overwhelming you and your students. And we design the topics, so probably like a 15 minutes per each sub modules. And then for worksheets, we have at least 1 worksheet for each module. And also we have class, quiz, homework, and those could be utilized as a in-class activities or at home homework. And for the in-class activities, all 15 modules have Jeopardy Jeopardy activities, and many of modules have additional activities to reinforce learning and include hands-on learning elements. And lastly, video. There are some sample videos included, and in the Moodle, it is all kind of embedded in the PowerPoint presentation or the separate resources. But if you come to this Instructor Toolkit, you will see a sample of videos such as interview with energy efficiency professionals, code officials' careers, and the video for heat transfer and insulation, a video for HVAC equipment, energy efficiency basics. Next, please. And on our program webpage, if you click access our Moodle, then you will come to this Moodle website. So if you have not signed up for Moodle yet, this is the time. So let me do a quick little survey. So, on the Zoom, there's like a reaction. So you can raise your hand. So raise your hand if you have signed on our Moodle and have come to our Moodle site already. If I don't see hand, hey, I see Eric's hand. Anybody else who already signed in and then came to our Moodle site? Yay, Amy, I see your thumbs up. And Francis, thank you. Oh, so it seems like then many of you have not signed up. So I will give you 2 minutes. So there's a link on the chat window. Go there, click that learn.smartenergy.illinois.edu. And it's easy to sign up. As you can see on the slide, Linda, maybe you want to move that chat window. It appears to be as a black box there. Yeah.
Sorry. And
So,
sorry, Sumi, we are going to have an activity later on that allows you to go get into the Moodle site and poke around and find resources for a sample syllabus. So if you could log on right now, that'll prepare you for that activity.
yes. So the login or sign up site is looking like that. You need to create your username and password, and then it will ask if you're instructor or consultant or student. But if you would like to have a full access, which means the PowerPoint slide and also answer keys to all the questions, you can just select, the instructor. That will give you the full access to all the materials that we have developed. So please do sign up now. If you don't do it now, then you will have another chance that when we go to the breakout room, then you can access or create the login. Next, please. And then this is a short video, and this is to just show you how to navigate the Moodle. So,
For your interest in our building energy fundamentals
so
program.
hold on.
Video
Yeah. So
how to access and use our educational materials. The education fundamental.
Linda, there are 2 videos
Access the
playing
materials.
at the same.
Signing up is quick and easy. Click on our Moodle page.
Okay. Oops. Sorry, just so it, and also this video, the audio was kind of a little bit the voice was a little soft. So if you could increase your volume of your device, that'll be helpful. It's just 2 minutes, and it shows briefly how to navigate that Moodle site. So when Linda is ready, we can watch that video. Linda, ready? Almost. Sorry, a little bit technical difficulty here.
Thank you for your interest in our Building Energy Education Fundamentals, or B Fundamentals program. This video explains how to access and use our educational materials. You will need to create an account to access the materials. Signing up is quick and easy. Click on our Moodle page to get started. Be sure to indicate whether you are an instructor or student. We have special instructor-only resources. Our curriculum is free to use. There are 4 groups of modules in our B Fundamentals program. There are 4 intro modules. In our last group, Advanced Modules, there are 3 modules: Beyond Code, Net Zero Buildings, and Existing Building Renovations. Now let's take a look at an example module from our Envelope group, Envelope and Insulation Fundamentals. For this module, there are 3 subtopics as well as activities, which include worksheets, a Jeopardy game, and other activities. Let's take a look at the first subtopic in this module and see what it contains. Here's where you will find the presentation slides. The PowerPoint is for instructors and the PDF is for students. The PowerPoint instructor slides contain detailed lecture notes and context for the slides that will be helpful. Activities for this module are located in a special Activities folder. Worksheets can be assigned as homework or in-class activities. We've created a review game based off the popular TV show Jeopardy! This is a building control layers activity where students are encouraged to practice reading construction drawings and identifying control layers. There's an online quiz that students can take to demonstrate that they have learned the material in the module. Students who receive a score of 70% or higher receive a certificate of achievement. Have questions about our curriculum or how to use it? Check out our Q&A page where we address common questions including what this program is about, what kind of content we include, how you can use the materials, and how you can contact us if you have questions.
All right, thank you. All right, that was a quick overview on how to navigate our Moodle, the curriculum site. And now we're gonna go to slide 33. And then Sean will take it over from here. Sean?
Thank you, Sumi. So I'm just going to be quickly going through one of our modules just as an example so you can see what's in it in a bit more detail before we get to our activity. So we're going to be looking at the Energy Codes and Standards module. You want to go to the next slide, please?
And this is just a portion. This is one of the subsections of that module.
So here we're covering that the energy code is one of many building codes. You've got fire, mechanical, plumbing, accessibility, structural. Energy conservation, as we noted before, kind of gets lost in the shuffle as most building inspectors are focused more on the health and life safety aspects of buildings. But the energy code's an important component of that. It can have a big impact on the health and safety of buildings. And then there's also the obvious impact on its energy consumption over time. So the purpose of our energy codes is to create a standard that can make buildings safe, healthy, and accessible while also minimizing the energy and money used for keeping those buildings comfortable and safe. Again, noting here, it's one of many codes that applies to buildings. Most other codes are focused on health and safety of buildings, accessibility in buildings, where the energy code is that primary focus on energy conservation. So what are those building energy conservation codes? Energy codes establish a minimum requirement for the design and construction of energy efficient buildings. So this is the kind of bare minimum that must be achieved. The energy codes aren't intended to prevent the installation of any material or to prohibit the design or method of construction that might be more advanced. Again, they are bare minimum requirements. You can always go beyond the code. That is encouraged. Next slide. The energy codes apply to residential and commercial buildings. For residential buildings, we need to know, what's the difference between those two structures? How are those defined in the codes? So residential buildings get a specific definition: detached 1 or 2 family dwelling or multifamily building, housing 3 stories or less. Some local codes may adjust that a little bit, but in general, for application of codes, that's your residential building definition, where occupants are residing on a primarily permanent basis. It's usually going to fall under that residential definition. For commercial buildings, that's everything else. So even if you have multifamily buildings that are higher than that 3-story requirement, those will fall under the commercial provisions. Within the commercial provisions, there are some specific residential requirements. But in general, this is how the code defines residential versus commercial buildings. The codes also specify different requirements for existing buildings versus new buildings. For new buildings, it's going to be pretty much anything that requires a construction permit. Obviously, you're starting from a base blank slate there. And so all the requirements of the energy codes would apply to a new building. Where existing buildings, again, the energy code is triggered by the requirement for a permit, but its additions, alterations, or changes of use or occupancy type in an existing building are going to trigger energy code requirements. The difference for existing buildings is it's a little bit more selective. The energy code doesn't require you to make changes to a building system that you're not modifying in order to incorporate the requirements of the energy code on the system that you are modifying. A really common example is roofing systems. If you're adding insulation to the roof in order to meet the minimum requirements of the energy code, it's not going to require you to adjust the height of parapet walls or roof curbs for HVAC systems, as those are separate components of the building. So for existing buildings, the code is set up so that you're modifying your modified sections of the building to the extent possible, giving existing constraints of other unmodified portions of the building. The energy codes are also set up to allow for different climate zones. As we know, the way buildings are conditioned in the south is very different from they are conditioned in the far north. Arid climates versus humid, moist climates. All of these have different impacts on how the buildings experience loads from the environment. And so the codes have specific region-based requirements based on those climate zones. So next we'll get into energy code development and adoption. The development process, model energy codes and standards are typically developed by a few national or international organizations. Primary examples are ASHRAE's 90.1 and 90.2 standards for commercial and residential. And on the international side, the International Code Council develops the International Energy Conservation Code, which by and large is used for residential and is kind of mixed a bit with ASHRAE as far as commercial energy code compliance adoption. But the nice thing about the IECC is it's a single standard or a single code that it contains both residential and commercial provisions, where ASHRAE, you've got 2 separate standards, one for commercial, one for residential. So again, here just looking at this is the ASHRAE standard. For both IECC and ASHRAE, they are updated on a 3-year cycle. So as we're noting here, 2016, 2019, 2022 for ASHRAE. For the IECC, they come out generally the year or 2 after the ASHRAE code, as the ASHRAE standards tend to inform what the Energy Code Council puts into the IECC codes. So those will be the 2018, the 2021, and the 2025 code cycles. Something else to be aware of is that the energy codes can be amended by local adopting authorities. This can be at the state level, can be at the county level, it could be at the national level. depending where you're at. Primarily in the US, it's the state or county level is going to be adopting and enforcing the code. So just an example here in the state of Illinois, we've adopted the 2018 IECC with some amendments in the state. And then even locally within the state, the city of Chicago has its own amendments to the Energy Conservation Code. Just another example of Energy Code amendments here, we're looking at Hawaii. So they are currently on the 2021 for state facilities, but for private sector, it's being adopted on the county level and is kind of in the process of doing that. So not all counties have adopted yet, but they're in the process of moving to the 2021 IECC. So now looking at Energy Code compliance and enforcement, building design and construction professionals are required to comply with the Energy Code. And so training and education of the Energy Code's requirements is important for them. Understanding how the codes are laid out and what they're covering is important as well. So the Energy Codes are going to affect the design and construction for the opaque assemblies of the building, the wall, the floor, the ceiling, the transparent assemblies, doors and windows. The heating and ventilation systems all have specific requirements, lighting systems and equipment, and water heating systems and equipment. An example of how the Energy Codes are going to impact design for construction of homes. The code does allow flexibility in how to comply with the code. So here we're looking at a couple of examples. Home builders can use either 2x6 studs for added cavity insulation depth, and that can reduce or eliminate the need for continuous insulation on the outside of the envelope. Or they can use the standard 2x4 wall that's more typical of common construction and include some continuous insulation on the outside. And both of those are compliance methods for meeting the Energy Code. Similarly, for HVAC equipment, the Energy Code provides criteria for size and efficiency of HVAC systems and equipment, but doesn't specify you must use this particular type of system for efficiency. It allows that flexibility to pick and choose the systems that are most cost effective for your project, as long as they meet these minimum requirements and are properly sized for the loads in the building. Last, looking at criteria for efficient lighting and controls of lighting systems. The Energy Code sets up minimum requirements for the installed lighting intensity in terms of watts per square foot. And then also has mandatory requirements for how that lighting is controlled. And that's going to impact both interior and exterior lighting systems. And also it touches on seemingly, systems that, might be forgotten or seem insignificant. On the residential side, residential hot water, it's not usually a large load to the building, but the Energy Code still covers it and has mandated requirements for minimum efficiency for water heaters and the control systems that operate those water heating systems. So once you've worked through the process of your design and buildings, how do you then display compliance with the Energy Code? On the residential side, there's usually a compliance certificate that's installed in the building. For commercial buildings, there are software programs that can be used. And then displayed here on screen is specific software developed by the DOE, ResCheck and ComCheck, that's used for prescriptive code compliance using an insulation trade-off methodology where you can trade slightly less insulation in one area by increasing insulation in another area of your building to meet minimum code compliance. And then moving into how do we enforce the building code? That's where building code officials and authorities having jurisdiction are involved and need to understand what the minimum requirements of the Energy Code are. So code officials are going to be reviewing design plans, inspecting construction work and the process of putting the building together. And then at the end of the project, they're going to be issuing those occupancy permits and construction completion permits for the project.
Thanks, Sean. I can take over from here.
All right.
So this was just a mini section of our introductory to energy codes. If you wanted to check out the other sections of this module, you would find one section on the benefits of energy codes and another section on common myths about the energy code. And then our following module talks about navigating the energy code. So this is where you would actually get into how to use the code, what's in the code. There's some fun exercises to try to get students comfortable with the code. So just a few ideas. Again, these are meant to be basic. So a lot of existing professionals may already know this stuff, but if you're being introduced to it the first time, you know, learning about what an energy code is and who's involved could be really helpful. So we wanted to just demonstrate a few of our activities. So we're going to do that together, and you can type your answers in the chat. We're going to do a portion of our Energy Code Jeopardy game, and then we'll do a little portion of one of our worksheets as well that's related to the content that Sean just taught. So here you get to test your knowledge. All right, we start with easy energy code for 100. True or false? Energy codes affect the design and construction of buildings. You can put you can just shout it out or put it in the chat. Quite true. Very good. Yes. So good. Next, we hope so. Getting some good answers here. Energy codes and standards apply to two general types of buildings. What are they? Just put your answer in the chat. Okay, yeah, we've got commercial, residential. You guys are experts. All right, next one. The energy code is generally administered on the blank or blank level. This is geography here. What levels are they administered on? Okay, we've got local or state. Very good. Yep. Municipal, county, state. Yep. Energy codes and standards apply to both blank construction and blank projects. New and remodeled, good. Alteration, yep. Ugly and beautiful, love that one. Yeah. Okay, name at least, the last one, code applied for 500. Name at least two major roles building code professionals play. What did they do? Got enforcing and plan review and inspection. Yep, yep. So review design plans, inspect construction work. Sometimes they issue permits. Very good. So you are all experts. We're going to go on to this worksheet. This worksheet is meant to try to get the students to have a good feel for these different organizations that are responsible for implementing or adopting energy codes. So what we're going to do is we're going to match the organization or group with what they do. So state or local governments, what do they do? Which of these 4 sections would you say they, or these 4 answers would you say they focus on? Okay. The state or local governments adopt or amend the energy code. That's what I've got. I've got an answer of 2 for some. Yep. Okay. Oops, sorry. I just gave away the answer. International Code Council. What do? They develop the code. Yep. Architects and construction professionals. What do? Make sure designs comply. Yep, 1. And then finally, building code officials review design plans, inspect and issue permits. We had a few other additional groups that we added, but for this slide, I thought I'd keep it kind of simple. So this gives you a feel for the kinds of review activities to reinforce learning that we've made available to you, and we hope that you will find some of them useful. Okay, now we're going to take a little bit of a break and get into groups. We'll give you maybe a 2-minute water break, or go take a little break and then join your group. We'll have 3 different groups, and what we're going to do is we're going to take a sample syllabus. This is modified slightly from a syllabus that one of our instructors sent to us that they were considering using our B curriculum. So what we would like you to do is get in your groups and go to our Moodle site and explore a little bit. So find the presentations and the activities or resources that could be used to support this topic. So we've got, a topic on energy audits of existing buildings. What kinds of modules would be appropriate for that? Are there some activities that you could use? And then you can see there's some envelope topics and some mechanical topics and ventilation topics. So what our goal here is to just get you comfortable with the Moodle site, help you get a sense for what's there, and then hopefully as you're designing your syllabus or your curriculum, you can know how to turn to our content to support what you've got. So I'll be starting the breakout rooms shortly, and and you will need to open up our Moodle site. We'll put that in your chat box. We'll also put a link to a Jamboard page where we'll be writing answers down in this little chart. So let me just start the groups and go ahead and take a little break, and then join your group and we will get started.
So Linda, you're gonna assign people to the
yes,
group. They don't need to do anything,
that's
right?
Exactly, yeah. So we'll assign you to a group. And I am opening up the rooms now.
We can go ahead and get started. Has everyone got access to the Moodle site now where they can access the activities and everything? Okay.
Yes.
So I think probably the easiest way to do this is everyone had a link to the Jamboard where they can access that as well. Okay. I think the easiest way to do this is, there's some examples dropped here already, but if you click on the sticky notes on the side, it brings up this sticky note window. From there, you can type in a response and drag and drop it into whatever block. So if you want to just kind of scroll through the Moodle page, compare that to the list of topics here in the syllabus, and then just drop sticky notes into the acceptable areas. Maybe we want to do, a couple of you look for one topic, a couple of you look for another. So we're not all kind of duplicating work here. I'll clear out these examples here so that you all can have a blank slate to start from.
Sure. Anyone have something they particularly favor?
Well, Deborah, since you were asking about the HVAC stuff, maybe you want to do the HVAC manual J calculations and ventilation requirements there at the bottom.
You know what? I'm actually on my phone and
Oh, okay.
I'm multitasking today, so I'm not going to do this. I'm just going to
Okay.
watch others do it.
Yeah. Well, so this is Eric. I can do that part.
Okay. Amy, you want to pick maybe the top two, and then Chris maybe do the middle two?
Yeah, sure.
If you have any questions about navigation or anything along the way, just let me know.
I should probably say that I've looked through all of the modules previously in developing training for Hawaii. So
you're going to be very familiar then. I think we've got about 6 more minutes here before we go back to the main group. So. And Deborah, we do have a manual D module as well. And that does cover kind of the basics of how that manual D is used. It goes through the ACA speed sheet. So it's kind of, again, it's introductory level as the speed sheets are kind of simplified versions of those design manuals.
Mhm.
But we do have that module is available.
Great, thank you.
Yeah, those were fun for me because I'm a mechanical engineer with a specialization in building energy systems. So.
Kind of where the rubber meets the road in some ways.
Mm-hmm. Looks like you're finding things pretty quick there. Any navigation issues for our two new people that Eric's accepted since he's already dug through it all? Okay, so looks like we're going to be heading back to the main room here in about a minute. All right, there we found the existing building section. Yeah, looks like you found most of the materials and stuff pretty well there. Just before we head back to the main room here in the last 30 seconds or so, any issues with navigation? Is it easy? Is it? All right, great. Got some thumbs up there. Perfect. Well, we tried to make it easy to get through and navigate. So that's good to hear.
Amy, were you able to connect as an instructor?
Yes, thank you, Eric.
All right, we'll be back in the main room in 2 seconds. I'll see you all there.
Yay, we're here.
Welcome back, everyone. You made it.
That was a little crazy.
Was it a little crazy? Okay. Well, I can share a little bit of of our group's work.
Yeah.
Hopefully you had enough time to kind of get into the modules. We did notice that if you sign up as a student instead of an instructor, restricts your access a little bit. And you have to kind of enroll in a course to see the content. So make sure that if you are signing up, you sign up as an instructor. Anyway, we identified a bunch of different modules that relate to all of these different topics. And pretty much, you know, just going by the titles and then getting into the sub modules, it was pretty straightforward in figuring out what we wanted to do. We looked at a couple of the activities. There's some pretty standard worksheets and Jeopardy games for every module that we saw, but there was a control layers drawing activity that looked good for foundations and floor systems. There's a heat transfer lab that we think could be interesting for fenestration and walls. And then for air infiltration, there was a duct design, or for blower door and duct leakage testing, there was a duct design activity, which looked interesting as well. And we didn't make it all the way down, but anyway, we got to explore a little bit. Any other thoughts from people before we move on to our discussion?
Yeah, just a reminder, you know, once you log in first, you know, it will ask, if you click the module or sub-module, it will ask you to enroll as a student. And Moodle kind of treats everybody as a student, even though you signed up as an instructor. Moodle kind of treats everybody as a student.
Okay.
And there are different types of students, and your instructor type of student. So that's a little confusing in terms of student, but it'll ask you to enroll. So please click enroll. That's the way that you get access to everything.
Okay, I didn't realize that was what instructors had to do too. Okay, good to know. All right, so we want to just have a few minutes to kind of learn from you. You're the ones who are teaching this curriculum. You're the ones who are interacting with professionals. We'd like to just open it up for discussion. I'll take some notes. This is the next portion of our Jamboard. But we want to know from you what the greatest training needs are related to energy code and energy efficiency fundamentals in your different fields. What do you see as the greatest training needs? And you can just feel free to shout it out. I'll take some notes. And I'm going to stop the share, but you can open up the Jamboard. This is the next slide, slide 4.
I think basically the envelope is the first thing to consider, of course, and then the infield with the equipment and everything like that. That goes hand in foot with the design on how it's all going to work. So, but the envelope is usually first.
Okay, thanks.
Yeah, and having an understanding of load calculations and air distribution goes along with them.
So load calculations. That's a big one. It came up in our needs assessment a lot. People don't know how to do load calculations. Yeah. What else do you see? What are the big needs?
Well, this is Eric Holderup. I don't know exactly what the priority is kind of nationally, but especially in California, energy modeling is used for code compliance very broadly, and at least you know, an awareness of how the performance paths work might be useful. If not, you know, sort of an exercise on kind of how to use them.
Thank you.
One thing I noticed is basically when we the residential and not so much the multifamily, but the residential, it's always sort of design build, and the architect will indicate that they have to provide calculations according to that. Unfortunately, inspection, we don't get that, or we don't enforce that we get that before we give a permit. So I see that's a tripping point basically. because the contractor has to see what's available also right now with this time of supply and demand. You have to choose a furnace or an HVAC system that is going to provide the needs for it, and pricing and availability come in nature too. So it's sort of convoluted right now because of the economy and everything, what we're going through. But yeah, I think as far as an inspector, we should ask for that proof of where they came up with their findings for the ratings, and coordinate that with the insulation of the envelope too, because if you're going to foam insulate the entire structure, of course, it's going to reduce the needs of that, but you have to consider that, and you have to check to see, make sure he considered it too, for energy efficiency anyway.
Interesting. Yeah. So there's different competencies that we need from different individuals, and the code professionals may have some different ideas. Yeah. Anyone else?
I just want to share, this is Gabriella. We have run programs for many years for high efficiency buildings and now the net zero buildings. And then we've gone back to actually collect the performance data. And, you know, the designs may look great up front. The energy models that people give us look good up front, but then the actual performance is a totally different story. So some of the loop has to be closed, because otherwise I feel like this is a waste of time.
That's really interesting. What would you say? How do we close that loop? And Deborah, you were going to speak as well.
I'll let Gabriella speak first, and then I will.
Well, I mean, you know, I'm in a very different position in the sense that we are a foundation that makes grants. And so now we do require actual submission of performance before we make those final grant payments. So, but we're not in the real world. I'm not quite sure how to address this in the real world yet, but it has to happen, because the data that we've run, so many of the buildings are just not performing the way they were modeled.
Yeah, okay, so here's what I would say. I think we need some people to go out and not just show that there's a mismatch between the modeling and the performance. I think we should do some analyses as to why. Is it some of the assumptions in the modeling that's off? I mean, it will take some data analysis, right, to do that, to be able to break down the different parts of the building. And it's not necessarily easy, but I do think it's doable. It makes some great projects for master students and PhDs. But I think we really need that information, because if we're using modeling that's pushing us in a direction that doesn't actually turn out that way, then we're not going to get to the kinds of buildings that we need for stabilizing climate. And billions of people depend on us doing this so that we can keep the planet, at least their part of the planet, habitable, right? And then they'll affect the rest of the world when they end up being climate refugees if we don't do a good job. So I would suggest that we do that. But then the other thing is, we need to find the ones that did perform well. And let's case study them. And let's case study the ones not that cost a fortune more. I mean, I remember when LEED Platinum, and I'm not necessarily a fan of LEED, but you know, it's what we've got. And but when we first started with LEED Platinum, and the examples came out of buildings that didn't necessarily cost more, or that cost so much little more that the energy savings, there was a net positive cash flow. And that those examples, this, you know, what we want to shoot for, because I'm concerned that if we just teach the process and people just, let me be a little more blunt. So I have two sons who are both builders, and regularly at holiday dinners, they say, Deborah, stop improving the energy code. Our customers want a bigger kitchen. And if they have to spend it on more efficient homes, they can't get the bigger kitchen. And my response is, oh, be responsible adults and educate your consumers. And, you know, we've got a planet hanging in the balance, and that's an ongoing conversation. But I do think we need more examples that are great examples, because both consumers and the employers and the employees will then set that in their sights instead of just focusing on how do you do the calculation. Oh, did we meet the code? Oh, okay, good enough. We're not in a situation for good enough.
And this is Gabriella again. I guess if I said I didn't really know how to do this in the real world, there are definitely things that we have encountered along the way. I mean, some of them is really workforce training, you know, in order to get folks to really, to get these really super quality, high performing envelopes, you know, we really have to train the people on the work site to do that kind of quality work and go back and test. And the other thing that's also become really important is basically real-time load-specific monitoring available so that it is easy or fairly straightforward for whoever's operating the building to see right away how that building is performing and, you know, identify fairly quickly where there are issues that need to be corrected.
Interesting. I really like this discussion because I think it gets at something I'm seeing more and more, which is the promise of energy efficiency is so often not realized. And there's many reasons for that. It could be things aren't installed properly, or, you know, controls aren't maintained. You know, building automation systems are hard to keep up with, right? So what are those gaps, and can we teach students, you know, what is that work site training that can teach students to, you know, to make sure that things are installed properly and controlled properly and operated properly, and tested, right? So that what you said is, I think, really important. We need more testing, we need more load specific monitoring, and can we teach students to do that?
And then the one other thing that I would add is, you know, up until now, when we've begun to actually hold folks accountable for the performance of the building, that hasn't been the case. So we've had a lot of issues with equipment performing the way it should. You know, we get CO2 sensors that don't work. We get meters that don't work. We get dampers that don't close properly and throw off all the ventilation. The list is endless, really. So the equipment manufacturers up until now have not really had to make sure that their equipment really delivers. So there are so many aspects to this, and it all comes together when you are asking people to really design these high performance or net zero energy buildings, because then you have to be accountable and your margin of error is a lot smaller.
So a lot of this falls under the commissioning of the equipment. When the equipment is installed, as a building is being erected, the commissioning of the equipment is that analysis that they have to go through on every piece of equipment to ensure that it's meeting the required energy saving. So that kind of the performance of the commissioning on the equipment falls under the construction aspect. Did the contractors actually install it according to the specifications of the engineering design and the specifications of the manufacturing? When they start cutting certain areas in the installation process, that starts reducing the efficiency of the equipment and the performance. The same goes for when they're erecting the building. They're using lower grade materials that were not the ones that were specific, because they're trying to provide cost savings. So when you start making these changes during the construction and installation process, that ultimately is going to have that effect that at the end, when the building is erected, it's not meeting the design requirements.
Yeah, so I would also say that I'd love to see us changing the standards of when the builder gets paid. The builder should get paid after the commissioning, not before. And there's also recommissioning, because just because it works right at the beginning, as you say, Gabriella, that won't necessarily stay that way. I love the idea of looping back to the manufacturers when it doesn't perform, and that the manufacturer should cover, and it would be interesting for the construction industry to ask for this, not only the new unit, but the labor to replace it, because that's when it doesn't happen. And I can show you on my campus a building that got an award for being an energy efficient solar design that I knew wasn't a good design, but it was decades ago when I was young and didn't have as much voice as I have now. It never worked the way it should have worked. And all it needed was another couple of ducts from the south side to the north side to bring the solar over. And instead it overheated, underheated, and needed fossil fuels, fossil fuels to work properly. And that is not a lone wolf story. So I think if we're really going to fix this system, it would be great if when you get your next grant, the focus could be on, here's some designs that have vetted out well. And so if you're going to do net zero, or you're going to do high performance, or if you're even just going to do well done air sealing, green construction, and electrifying the building, here's some models that have been shown to perform well. And let's get into those details and have the students study that for the final. And then the second piece is on the site, the work site. Yes, you can do training on work site, but a lot of the things we've just talked about, you can also teach in the classroom. And so I love this. I think we've got really something very important here. I would like to work on moving that forward. Anybody else who does too? I mean, because, you know, running the Clean Energy, National Clean Energy Workforce Alliance, these are the kinds of solutions we're looking for. So anybody who wants to work with me on it, just shoot me an email and we will put you into that. You don't have to do the work, but share your wisdom like you just were, so that we can make sure these solutions get created and more on a system scale. That was great.
Thank
It's
you,
the best
Deborah.
conversation I've heard in a while. Yeah.
I have been taking notes. I love the idea of more examples of designs that have worked and designs that don't work, right? And why does this not work? That close attention to detailing. Eric, what do you think?
Well, kind of to build on that and just thinking about what's useful for instructors and for students. You know, I find when I teach college students, one class we take a field trip to go up to top of one of the buildings, one of the penthouses, to see one of the huge air handlers, and they could actually walk inside the air handler and see this 6-foot tall fan and these 20-foot wide cooling coils, and start to get an understanding of what these building systems actually look like that they can't get in the classroom. That said, that kind of information, pictures of systems, short videos of systems, to kind of supplement the examples that were just being referenced.
Perfect.
Not necessarily high performance buildings, but just, you know, what the heck does the inside of a furnace look like? Or, you know, if we could, a lot of these kind of things are hard to come by when you're sort of putting together a class. You know, you Google pictures and you steal pictures from the internet and you try to find things, but nothing's, you know, they're often not quite what you're looking for. So I would think, you know, good pictures, images, videos of building components, systems, and things like that could be useful tools.
Absolutely.
I may be curious what other instructors think, whether that makes sense to them or not.
Well, I think that makes perfect sense, but what you can do is that you can partner with your facilities department and then have them do a tour of their facilities where they have all this mechanical equipment. You have it already in the building, you have a commercial building, and then all you have to do is just reach out to the facilities department person and ask them, can you give us a tour so that we can show these systems around? And the nice thing about the type of facilities that we used to teach is that they have almost every type of system you can imagine. Spread out through.
Yeah, that's good. You know, I've been teaching energy management for 40 some years and renewables. And so I have my students go out into buildings in the community and they do an assessment. They do between a type 1 and type 2 audit. And then they present the results and they take pictures. And then you just keep the best ones. But also there's a lot of textbooks. So we're doing a textbook convening. It'll be in June. And so, you know, if there's things you guys want in the textbooks that aren't in the textbooks, if you could let me know about that as well. This conversation was super helpful, and I hope we'll be able to continue it and
absolutely
go from there.
Thank you, Deborah. Michael, and then we
Thank
have
you.
to go back to Sumi.
Yeah, I just want to add one more thing. If I put my former life as a contractor hat on, I think you're all right. You're all on the right same page. Jose, training, that's very important. Gabriella, I can see basically where you're granting money. You want to make sure it's efficient and it's used well. Deborah, I can see your point of view too. A contractor in our life, I work for a huge electrical contractor. We did about 400 million a year in the Chicagoland area. And basically, I think any kind of healthcare project or a federal project, military project, which is federal, some state, although I've seen some state projects go south too. They basically really do hold your feet to the fire as far as making it. And they do have a good commissioning exercise in those larger jobs that are well funded. When you get to the smaller businesses of, you know, maybe a 7-story and it's going to be mixed retail and residential or something like that, the first thing that's everybody's looking for is, hey, how can we cut this money? And unfortunately, the design build process and the value engineering, a lot of the energy conservation leaves. It might still be in the specifications. So the people that are trained as an architect, that's fine, the engineers. But if you don't have a good commissioning program, you can't really force that, because if I put my inspector hat on, then I'm looking at something, I've got a limited amount of time. I ask for a report, I don't get it, but meanwhile, I've got to approve it because they need occupancy. So it's a matter of enforcement and really getting that commissioning done professionally. And you know, some jobs can afford it, and self-performing commissioning, that's sort of stupid too, because you're asking a guy that took all the shortcuts to say, is it okay? And sure, he goes, hey, yeah, it works perfect, you know. So in the real world, it's a little bit different from where you're teaching professionals into the trade. I think the trades are well trained. It's going to take longer to do it efficiently, and they're looking for a paycheck, and the longer the job takes, they're happy about it. That's no problem there. But you can see the problem of the reality of the real world goes that with contractors and people trying to cut corners. That's the real issue. So, but I'm 100% with all of you folks. I mean, I think this is a good program. I'm really appreciate it.
Thank you, Michael, and thank you, everyone. We do need to close up, and I need to give the time back to Sumi. Thank you. I'm leaving the Jamboard open if you want to add your thoughts and your notes and continue this discussion. You can, it's the same link that we provided earlier. You should still have it up on your browser. Feel free to add your feedback there. Sumi, let me share my screen and you can close us out here.
All right. So on the Jamboard, if you click to the next, you know, on top, you can go to the next page. So there's this sticky notes thing for this discussion. So this has been really helpful for us to hear everybody's voice. And now our next big thing is to improve our curriculum and the program, and we need your help. So there are 3 action items that we're gonna ask, we are asking your help to measure the outcomes of this program, and then also some, other things that we need to improve.
And Sumi, can I just interject here? It was interesting listening to all of you talk about the importance of testing and making sure that this is actually working. The same goes for our curriculum. We want to make sure it's working, and we need some metrics to be able to do that. We need people like you to share what you've learned and what you think. We need input from your students to see how much they were able to learn from our curriculum as well.
Mm-hmm. If you remember, Ian from PNNL dropped in and gave us a little overview. And then, so this program is funded by Department of Energy. And, we need to prove the success of this program to continue to develop programs like this. And for us to show the proof of success is the metrics and feedback from you guys. So first item, so we would like to, check in with you. I don't know, the email would be better or a phone call is better, but something. So if you have, any questions, please feel free to reach out, and we might send you some emails and newsletters, and please do not ignore us and just tell us how things are going. And then second, the metrics. So we would like to know which modules you're using and how many students you have, taught using our curriculum. And third, we would like to get feedback from your students too. So please ask your students and share their feedback to us. And if you look at the chat box, there's a link to the survey. So please click that link and give us a feedback about this particular today's workshop. So, that would inform us how to improve our workshops or improve our curriculum and improve our program.
And it also just has a little bit of information about, are you planning to use this curriculum in the fall? If so, can we contact you and get some information from you about your course?
All right.
And the link is in the chat now, I believe. So
yeah,
please, before you take off, complete this survey. It's short.
Okay, so Francis asked, how do you get feedback from students when this is just part of the lesson? So, we totally understand, and this is, we designed this whole curriculum so you can pick just a little bit of it, not just replacing the whole course. So we might come up with just a sample question, and then, you just teach your students using our curriculum. And then you have quiz, about their knowledge level or just how they like the content, how it's organized. So we might develop a sample feedback survey that you can easily just download and then print out or, send it to your students. So hopefully, Francis, that could be an answer to your question.
The real answer is it's going to be tough to suss out like what you have taught and what involved our curriculum. But right. We are going to do our best to be able to assess this.
And also, some of the instructors who already kind of use some of our curriculum just informally send us, the email like, hey, Sumi, last week, we, talk about envelope insulation, and we show the videos that you included in the V curriculum, and then, students really like it. As simple as that, that's also helpful for us to know. We want to know where and how people are using our resources and if they find it, useful. And that is the end of the presentation slide. And actually, the end of presentation slide is my contact information, which Abby just dropped in on the chat window. So you don't need to share the slide, Linda. So it's my email address and phone number. If you have any questions, please just feel free to contact us. And also, like, Deb mentioned some of the, things that's happening at the NCWE, text curriculum and textbook publisher events. So if you are involved in any organizations or project program, just invite us. You know, we are happy to connect with your own circle and, you know, just connect with other programs. And also, if you're instructors or training provider, if you want to have us as a guest speaker, we are happy to just drop in or just attend one of your classes and do a little guest speaking. We are happy to do that too. So feel free to contact us, and we really want to, you know, keep connecting with you, not just, you know, today is the end of the whole thing, but we continue to reach out to you. We will send out emails. We will send out quarterly newsletter, and we'll just, you know, occasionally just, you know, check in with you informally too. So thank you again for everyone who came here on Friday from Hawaii, Nevada, Illinois, and even Texas. So we are very happy to see everybody from everywhere. And if you want to stay a little bit longer to chat with us, we'll be here for a few more minutes, but it's top of the hour. If you have to jump off, we understand. And thank you so much. Hopefully we will see you again.